Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is count elements with maximum frequency. So according to the problem statement, you will be given array nums consisting of only positive integers. You have to return the total frequencies of the elements in the nums such that those elements have maximum frequency. Okay, so the frequency of an element is the number of occurrences of that particular element in the array. So let's say this array is given as input to you, and then in that case let me copy it here first. Yeah, now it's fine. So how many times each element is occurring? So how many elements are there? 1, 2 and 3 and then 4. Okay, so these are elements and I will be writing their frequencies here. So 1 is occurring 1 and 2 times, okay, and then 2 is occurring 2 times, and then 3 is occurring once, and 4 is occurring once. So what are the maximum frequencies here? What is the maximum frequency? First of all, it is 2. Okay, so how many elements are having frequency of 2? 1 and 2. Okay, so what is the addition of their frequencies? It will be nothing but 2 into 2. Okay, so 2 is maximum frequency and number of elements having maximum frequency. Okay, so we will simply return these two, the product of these two, and that will be our answer. Let's take another example. Okay, here it's 1 2 3 4 5. Everything is occurring once, as you can see. So 1 is the maximum frequency and 1 into 5 will be 5. So that is our answer. Okay, so it is pretty naive problem, you can say. It's not requiring much thought from your side, and the constraints also, you can see they are pretty low here. As you can see, the length of the nums array is of order 100 only, and elements are ranging from 1 to 100. So let's implement this. We will build this kind of map. Okay, so you can call it frequency map, and then we will, once this map is built, we will traverse this map and find out the max frequency that is there, or we can do this while we are building this particular map also. Okay, and once we are done with it, we will just find out how many elements are having this maximum frequency, and then we will multiply this maximum frequency with this count, the number of elements having maximum frequency, and we will be returning it. Okay, this product. So let's do this. Firstly, let me zoom out a little bit. Yeah, I guess now it should be fine. So firstly, we will be declaring a map. Let's pick Java today instead of C++. So in Java it will be a map interface, and then it will be of integer type, and key value pair will be, both will be of integer type, and let's call this frequency map, and hash map, yes, it will be. Okay, and yeah, so now making our map. So frequency map dot put nums num, and we'll be getting whatever is the current frequency of num, or by default we will keep it to 0. So frequency map dot get or default num. Okay, this will give us the frequency that is currently in the map. Okay, how many times nums is entered into the map, or else if it's not entered at all, it will give us 0 and we will add 1 to it. So now we are done building our map. We want to find the maximum frequency that is there, and we could have done it alongside also in this particular loop. So let's do that here only. So max frequency, initially let's set it to 0. So what we'll be doing is we will be updating our max frequency at every step here. So max frequency will be equal to math.max, max frequency that is there, and frequency map dot get frequency of current number. Okay, and we'll be taking maximum of max frequency and that frequency. So updating our max frequency here just now. Once we have this map completed or populated and our maximum frequency with us, we will be finding how many elements are having maximum frequency. Max frequency element count, you can say. Let's set it to 0 initially, and then we will be interested in entries in this map. So entry and frequency map dot entry set. Okay, and just we will be seeing whether how many elements are having this maximum frequency. So current element frequency will be nothing but entry dot get value. Okay, so since our map was having key value pairs, well, key was our element and our value was this, our frequency. So that's why getting value of the current entry, and if current element frequency happens to be equal to this maximum frequency that we are having, in that case we will simply increase the frequency element, max frequency element count, okay, by 1, and at last simply we will be returning the product of maximum frequency and max frequency element count. Okay, so that is the implementation, and let's try to submit for sample test cases first. Okay, running for sample test cases. Okay, it's getting accepted. So let's run for the final evaluation of all the test cases that are out there. So running for final evaluation. So as you can see, it's getting accepted. So this is how you will be solving this particular problem. And if you ask me about the complexities here, so they will be for the time complexity part, since we are only doing a linear traversal here in both of these cases. So in that case it should be order of n, where n is the size of the nums array that will be given to us. Okay, and what is the space complexity, how much space can we utilize in worst case? In worst case, as you see that in one of those examples it was mentioned, it was there that all the elements here you can see are occurring only once. So our frequency map will be having 5 entries, okay, which is equal to the number of elements in the nums array. So in that case it will be also order of n. Okay, So these will be the complexities, and yeah, that's pretty much it. And if you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.